Hi everyone, and welcome to this audiobook designed for the EWRB Electrician Regulation Exam. My name is Aria, and I work alongside Whitroy as an electrical tutor. This audiobook explains the exam topics in simple spoken language, making it easier to understand and review anywhere, anytime. Before we get into the lesson, I want to explain what this audiobook actually is. This audiobook is not a word-for-word reading of as NZS 3000. You must always refer to the real standard when you're doing electrical work or preparing for an assessment. What we do here is take the important ideas from the standard and rewrite them in simple spoken English. The goal is to make the rules easier to understand, easier to remember, and easier to revise, especially when you're listening on the go. So think of this audiobook as a learning guide, not a replacement for the actual standard. Alright, let's begin. Today in this part of the lesson we are moving into section 3 of as NZS 3000. This section is all about the selection and installation of wiring systems. The goal is to help you understand not just what the rules say, but why they matter in real installations. Wiring systems have to deal with heat, moisture, movement, sunlight, vibration, and all kinds of everyday hazards. If we choose the wrong wiring method, or install it poorly, we can end up with faults, shocks, or fires. So in this section we slow down, take each clause one by one, and unpack the key ideas in clear and simple language. By the end of section 3, you will have a solid understanding of how to select the right cable, how to support it, how to protect it, and how to install it in a way that stays safe for many years. Clause 3.1 General. This clause introduces the overall requirements for wiring systems in this section. It explains that the rules in section 3 set the minimum safety standard for selecting and installing wiring systems so the installation will operate safely and reliably. Clause 3.1.1 Application. This part explains that the rules in section 3 set out the minimum requirements for choosing and installing wiring systems. The wiring work must meet the safety principles in Part 1 of as NZS 3000. Everything in this section guides you towards safe, reliable, and suitable wiring for any installation. Clause 3.1.2 Selection and Installation. This clause tells us that wiring systems must be chosen and fitted so they keep people safe and make the installation work properly. The wiring must stop people touching live parts, either by strong insulation or by keeping live parts out of reach. It must also carry the required current safely, keep voltage drop within limits, and meet all the normal rules for conductor size. The wiring system must stay reliable, keep good electrical continuity, and allow secure joints and terminations. It must also be supported properly so it will not pull apart or sag. The chosen wiring must suit its job, including special requirements such as fire resistance or explosion protection where needed. And finally, it must resist environmental and mechanical damage, either by being enclosed or by other suitable means. The standard also reminds us that many cable characteristics matter, such as insulation type, conductor material, bending limits, temperature ratings, and how the cable handles tension. Clause 3.2 Types of wiring systems. This clause explains that each wiring system must either follow the methods shown in Table 3.1, or provide an equal or better level of safety while still meeting the rules of Section 3. Clause 3.3 External Influences. This clause introduces the general requirement that wiring systems must be able to operate safely and continue to function properly under all the environmental conditions they are likely to face. It leads into the detailed clauses that explain how to manage different types of external influences. Clause 3.3.1 General. This part explains that wiring systems must stay safe and work properly in whatever conditions they face once installed. The shape, design, and construction of the wiring system all contribute to how well it handles these external influences. The installation may also include extra protection or features that help it cope with the environment. The system must be able to protect itself against things like moisture, impact, dust, and other environmental factors. There is also a reminder that the IP classification system, in another standard, is a guide to how well equipment resists entry of water and solid objects. Clause 3.3.2.1 Ambient temperature. This clause explains that wiring must be chosen and installed so it can handle the highest and lowest temperatures found in its location. If materials are used above 60 degrees or below 0 degrees, you must follow the manufacturer's instructions. We also allow for expansion and contraction of materials as temperatures change. When current carrying capacity is taken from as NZS 3008.1, we must use a reference ambient temperature of 30 degrees for New Zealand for cables in air. For cables buried direct in the ground or underground conduits, the reference ambient temperature for New Zealand is 15 degrees. Clause 3.3.2.2 External heat sources. This clause explains that wiring must be protected from heat coming from outside sources, including solar gain. This can be done by shielding, by keeping the wiring far enough from the heat source, by choosing cable that can handle the extra heat, by limiting the current so the cable runs cooler, or by adding insulation where needed. If the wiring is inside equipment, accessories, or luminaires, it must be suitable for the temperatures it will meet inside those items. Extra insulation may be required if the temperatures are high. Clause 3.3.2.3 Presence of water or high humidity. Wiring must be chosen and installed so that water or moisture does not cause damage. If condensation can form and become a hazard, the system must allow water to drain safely through suitable outlets. If the wiring may be exposed to wave action or similar forces, it must be protected from excess movement and mechanical stress, using the other clauses that deal with mechanical protection. Clause 3.3.2.4 Presence of solid foreign bodies. This clause says wiring must be protected so solid material like dust or debris does not enter and cause problems during installation, use, or maintenance. If large amounts of dust or other substances are present, extra steps must be taken to reduce the buildup, because too much material can affect the cable's ability to lose heat and remain safe. Clause 3.3.2.5 Presence of corrosive or polluting substances. When corrosive or polluting substances are present, any wiring exposed to these materials must be protected or made from materials that resist corrosion. Different metals that may react with each other must not be placed in contact. Materials that can damage each other, or that may break down when placed together, must be separated. Some chemicals, such as esters, ketones, ethers, and chlorinated hydrocarbons, can affect insulation materials, so we must consider this when choosing conduits, enclosures, or cable types. Clause 3.3.2.6 Impact. This clause explains that wiring systems must be chosen and installed so the risk of mechanical impact is as low as possible. The wiring must be able to cope with whatever knocks or strikes it might face. The protection can come from the strength of the wiring itself, from where it is located, or from adding mechanical protection such as covers or enclosures. Clause 3.3.2.7 Vibration. Wiring that is exposed to vibration must be suitable for it. Any vibration strong enough to damage cables, fixings, or connections means the entire wiring system must be able to withstand constant movement without failing. Everything must stay secure and reliable under those conditions. Clause 3.3.2.8 Other mechanical stresses. This clause explains that wiring must be installed so that stresses do not damage the insulation, sheathing, or connections throughout the life of the installation. Damage can come from weight, movement, bending, or pulling forces. To reduce these risks, the wiring should be supported at distances suitable for the cable's mass, fixed in place using suitable fixings, and connected with fittings that reduce strain at joints and terminations. Bending must follow the cable's minimum radius, and the cable must be free to move slightly where needed so it is not pulled tight under tension. Clause 3.3.2.9 Presence of flora. Where plants or vegetation could create a hazard, the wiring must be chosen or protected so it remains safe. This may mean using a different wiring method or adding extra protective measures. Clause 3.3.2.10 Presence of fauna. Where animals or insects could damage wiring, the wiring must be selected or protected so it remains safe. Some locations require tougher wiring systems or barriers to stop animals chewing, nesting, or interfering with cables. Clause 3.3.2.11 Solar radiation. When wiring may be exposed to direct sunlight, it must be selected so it can handle the conditions or must be shielded. Sunlight can cause heating or ultraviolet damage, so the wiring must be protected in accordance with earlier clauses dealing with heat sources. The notes explain that many sheathed cables already have ultraviolet protection, but some colors or types may still need extra shielding, and the manufacturer's advice should be followed. Clause 3.3.2.12 Hazardous areas. Where wiring is installed in places with explosive gas or explosive dust, the wiring system must meet the special rules for hazardous locations. The wiring must be chosen and installed to prevent ignition risks and must meet the requirements of Clause 7.7. Clause 3.4 Current carrying capacity. This clause introduces the rules for choosing a conductor size that can safely carry the current expected on the circuit, taking into account installation conditions and any external factors that may affect the cable's temperature. Clause 3.4.1 General. Every conductor must have a safe current carrying capacity, as defined in as NZS 3008.1. The cable must be able to carry the expected current without overheating. When choosing the correct capacity, we must allow for external influences, including thermal insulation around the cable. In New Zealand homes, wiring must be selected with the assumption that thermal insulation in ceilings, walls and sometimes floors may be added in the future, even if it is not installed yet. The notes remind us that alternative current carrying capacity values exist in Appendix C, that building codes may require thermal insulation, and that modern cable materials may handle higher temperatures than older ones. It also explains that busbar ratings come from the manufacturer, with more detail in other standards. Clause 3.4.2 Operating temperature limits. The operating temperature of the conductor must not go above the maximum shown in Table 3.2. Most common cable types in New Zealand have normal operating temperatures of 75 degrees, although some special cables have higher limits. The notes explain that maximum temperatures may be lower in some locations, that some cable materials soften when exposed to heat, and that the temperature of flexible cords is based on a 75-degree rating. High temperatures may be allowed only if the cable is fully protected from mechanical strain and other stress. Clause 3.4.3 Conductors in parallel. Where more than one cable is run in parallel to share current, the combined current carrying capacity may be based on the sum of the individual cable ratings. However, parallel cables must meet strict conditions. Each cable must be at least 4 square millimeters. The arrangement of the cables must not restrict cooling. The load current must be shared evenly so one cable does not overheat. Equal sharing happens when cables are the same size and material, have the same length, are arranged so each cable sees the same conditions, and the positions of the phase and neutral conductors reduce the effects of mutual heating. An exception allows unequal sharing in some cases, but only if each cable is protected individually according to Part 1. Clause 3.4.4 Coordination between conductors and protective devices. This clause explains that the cable's continuous current carrying capacity must match the rating of the protective device for that circuit. This ensures the cable is never asked to carry more current than it can safely handle. For circuit breakers, the rating must not be greater than the cable's current carrying capacity. For HRC fuses, the fuse rating must not be more than 90% of the cable's current carrying capacity. This ensures the fuse will operate before the cable overheats. Clause 3.5 Conductor size. This clause introduces the minimum sizes required for conductors in different wiring systems. The aim is to make sure the conductor is large enough to carry the expected current safely and reliably. Clause 3.5.1 General. This clause explains that the nominal cross-sectional area of any conductor must not be smaller than the value shown in Table 3.3. The table lists the smallest acceptable sizes for socket outlet circuits, lighting circuits, signal circuits, bare conductors, flexible conductors, and aerial wiring. There is also an exception explaining that in some cases, smaller conductors may be used on socket outlet subcircuits if they still meet the requirements for voltage drop, current carrying capacity, and connection reliability. Clause 3.5.2, Neutral conductor. This clause describes how to select the minimum size of the neutral conductor. For a single-phase 2-wire circuit, the neutral must have a current carrying capacity at least equal to the active conductor, or large enough to carry the total current if more than one active conductor is involved. For multi-phase circuits, the neutral must be sized according to the expected neutral current. In many modern installations, harmonic currents can be significant. Some loads, such as fluorescent lighting, computers, switch mode supplies, and electronic drives, create third and higher order harmonics. These harmonics add together in the neutral conductor and can exceed the current in the active conductor. For this reason, the neutral in such installations must be sized to carry the highest load producing harmonic current on any phase. In consumers' mains, submains, or final subcircuits, the neutral must not be smaller than the associated active conductor when multiple phases are present. The notes explain that a harmonic load above 40% of the single-phase load is regarded as substantial, and that information about harmonic currents can be found in other standards. There are also exceptions describing situations where out-of-balance currents or protected neutral arrangements allow the neutral to be sized differently, provided the neutral cannot exceed the protective capacity of the circuit. Clause 3.5.3, Earthing conductor. This clause explains that the size of an earthing conductor must be chosen in accordance with Clause 5.5.3.3. The earthing conductor must be large enough to carry any fault current safely and maintain the integrity of the earthing system. Clause 3.6, Voltage drop. This clause introduces the requirement that voltage drop in a circuit must remain within limits so that equipment receives a safe and usable voltage supply. Clause 3.6.1, General. Under normal service conditions, the voltage at the terminals of any equipment must not fall below the minimum value specified by the relevant equipment standard. If the equipment does not have its own standard, then the voltage must remain high enough that the equipment can operate safely and properly. Clause 3.6.2, Value. This clause explains that the size of each current carrying conductor must be chosen so the voltage drop between the point of supply and the equipment does not exceed 5% of the nominal supply voltage. To calculate voltage drop, the current used may be the connected load, the maximum demand of the circuit, or the current rating of the protective device. Several exceptions apply. For final subcircuits with evenly distributed loads, only half of the protective device rating may be used in the calculation. High voltage and extra low voltage circuits are not included in this rule. When the transformer supplying the premises is dedicated to that installation, the allowable voltage drop may be increased to 7%. For standalone power systems, the combined voltage effects from the source and the installation must not cause the equipment to operate at an unsafe low voltage, and in these cases the total allowable drop may be 11%. Clause 3.6.3, Conductors in parallel. This clause explains how to calculate voltage drop when a circuit has conductors running in parallel. In this case, the voltage drop is taken as the drop in one conductor, with the current adjusted based on the proportion of current actually carried by that conductor. The calculation must follow Clause 3.6.2. But the current in the formula is divided according to the number of parallel conductors. Clause 3.7, Electrical connections. This clause introduces the requirements for how conductors must be connected so that electrical continuity, insulation integrity, and mechanical strength are maintained throughout the life of the installation. Clause 3.7.1, General. This clause explains that every connection between conductors, or between conductors and equipment, must provide a reliable electrical pathway, proper insulation, and enough mechanical strength to stay secure. The way cables are joined must suit the application, and the joint must conduct electricity at least as well as the conductor itself. There must be no unnecessary pressure on the conductor either before or after the connection is made. Clause 3.7.2, Connection methods. This clause introduces the different ways conductors may be joined or connected and the requirements for ensuring each method is safe and reliable. Clause 3.7.2.1, General. The method of connection must be chosen carefully. Factors such as the conductor material, the insulation type, the shape and number of wires, the cross-sectional area, the number of conductors being joined, the temperature reached at terminals in normal use, and protection against moisture and water entry all influence the correct choice of connection method. Clause 3.7.2.1.1 Common Requirements. This clause reinforces that the above factors must be considered so the connection remains electrically sound and the insulation remains effective. Moisture control must also be considered to stop water entering the joint or moving along conduits or enclosures. Clause 3.7.2.1.2 Aluminium conductors. Aluminium conductors need special care. Joints and terminations must use parts specifically designed for aluminium and must follow the manufacturer's instructions. When working with aluminium, the oxide layer must be removed, the softness of aluminium must be considered, and differences in expansion rates between aluminium and other metals must be taken into account. The conductor must also be protected from contact with dissimilar metals that can create galvanic corrosion. Clause 3.7.2.2 Preparation for connection. Insulation must only be removed as much as is needed to form the connection. When joining insulated conductors, the finished connection must have an insulation level that matches the original conductor. Any damaged insulation must be repaired or reinstated. Clause 3.7.2.3 Loosening of connections. Clause 3.7.2.3.1 General. Connections must be made so they do not loosen under vibration, material movement, or normal temperature changes. The connection must remain secure throughout its service life. Clause 3.7.2.3.2 Crimp joints. Conductors joined by crimping must use the correct type of crimping tool and the correct components approved by the manufacturer. When a crimp is correctly made, it forms a permanent and secure mechanical and electrical joint. Clause 3.7.2.3.4 Mechanical connection devices. This clause explains the requirements for mechanical devices used for connecting conductors. These devices must comply with an appropriate standard, must not rely on compressing the insulation to make an electrical connection, and must carry fault current safely. They must have a long-term current carrying capacity equal to the conductors, must not deteriorate if reused, must include the manufacturer's instructions, and must be installed exactly as the manufacturer specifies. Clause 3.7.2.5 Retention of stranded conductors. The ends of stranded conductors must be secured so individual strands cannot spread or escape. They must not be soft soldered before being tightened under screws or clamps. Clause 3.7.2.6 Mechanical stress. Cables and conductors must be installed so no unnecessary mechanical stress is applied to the connection or the conductor. Clause 3.7.2.7 Soldered connections. Where soldered joints are used, the design must consider mechanical stress and how the connection behaves during a fault. Soft soldered joints must not be clamped under screws or between metal plates. Soldered joints are not allowed for aerial conductors under tension. Clause 3.7.2.8 Flexible cords. Joints must not be made in flexible cords, except where the flexible cord is being used as installation wiring and the requirements of earlier clauses are met. Connections between flexible cords and fixed wiring must be made in purpose-designed devices such as flex connectors or cable couplers. Any flexible cord must be installed so that no undue stress is placed on the connections due to pulling, twisting, or sharp bending. Clause 3.7.2.9 Aerial conductors. Clause 3.7.2.9.1 Joints and connections. Connections in aerial conductors must not be soldered, must be reliable, must be protected from sun, moisture, and movement, and must be kept short. Where different metals are joined, galvanic action must be prevented by using suitable connectors. Clause 3.7.2.9.2 Prohibited joints. Certain types of aerial cable must not be jointed at all while under tension. This includes parallel webbed or twisted aerial cables, neutral screened cables, multi-core aerial cables, and cables made from different metals. Clause 3.7.2.10 Underground cables. Joints in underground wiring must be sealed to prevent water entry. Proper sealing ensures long-term reliability and prevents corrosion. Clause 3.7.2.11 Earthing conductors. If the earthing conductor is joined by soldering, the joint must be secured by additional mechanical means so the conductor remains firmly held even if the solder softens. Tunnel-type connectors used with earthing conductors must have either 2 screws or 1 large screw able to grip the conductor without cutting it. Where clamping over insulation is not necessary, bare conductors must be clamped directly using suitable ferrules or plates. Clause 3.7.3 Joints and cables. Joints and cables must be enclosed, typically in a junction box, to protect the joint from external influences. However, a cable joint does not need to be enclosed if it is not under strain, if it meets the requirements for proper connection, if any damaged mechanical protection has been restored, and if the insulation and sheathing are reinstated to an equivalent standard. Clause 3.7.4 Installation couplers. Installation couplers may be used for connecting cables, including flexible cords and rigid conductors, as long as they comply with NZS 61535. These couplers are designed for permanent connection and must be used correctly. Some require deliberate action to disconnect, and they must not be engaged or disengaged under load unless designed for that purpose. Clause 3.8 Identification. This clause introduces the requirement to clearly identify conductors so their function as active, neutral, earthing, or equipotential bonding is unmistakable. Clause 3.8.1 General. Installation wiring must be clearly identified so anyone working on the installation can immediately recognize each conductor's purpose. When colors are used for identification, they must follow the colors listed in Table 3.4. Green, yellow, or the green and yellow combination must never be used as active or neutral conductors in installation wiring. These colors are reserved for earthing and equipotential bonding only. Clause 3.8.2 Color identification by sleeving or other means. In some situations, conductors may be identified by sleeving or other methods instead of relying on the insulation color alone. Sleeving must use colors that match those listed in Table 3.4 and must be applied at each termination. Conductors with black or light blue insulation may be identified as active if sleeved correctly. Conductors with colors other than green, yellow, green and yellow, black, or light blue may be identified as neutral. Cores within multi-core cables that are not green, yellow, or green and yellow may be identified as earthing conductors when sleeved correctly. The sleeving must be color-fast, non-conductive, and suitable for the environment. Single-core cables that are not already green, yellow, or green and yellow must show continuous identification along their full length if used as earthing conductors. Clause 3.8.3 Exceptions and special applications. This clause explains where the identification rules of clauses 3.8.1 and 3.8.2 do not have to be followed. Clause 3.8.3.1 Protective earthing and equipotential conductors. A bare or aerial conductor used as a protective earth does not require green and yellow identification. If a multi-core cable includes a protective earth within a screened layer, the individual conductor does not need green and yellow insulation. The core may instead be marked at its ends where it joins the earthing system. Some insulated protective earths are made using materials that cannot be colored green and yellow. In these cases, sleeving at terminations is recommended unless the conductor's purpose is already clear. Clause 3.8.3.2 Active and neutral conductors. This clause describes situations where active or neutral conductors do not need to follow the color rules in Table 3.4. In multi-core flexible cables, each core may be identified by numbering, lettering, or other methods that clearly show its function. Flexible cords and cables may also use alternative identification systems, provided they match the relevant requirements in earlier clauses. Some aerial conductors are identified by small ribs or markings along the insulation rather than by color. The neutral conductor may use a special rib pattern that is repeated along the cable to make the identification clear. Clause 3.8.3.3 European Cable Identification Colors. This clause explains that some imported equipment and cables follow European color codes. These differ from NZS conductor colors but may still be encountered in practice. To ensure safety, the installer must confirm the function of each conductor when European coded wiring is encountered, particularly with imported appliances or lighting equipment. Clause 3.8.3.4 Aerial earthing conductors. Aerial earthing conductors must be identified directly at each end of their run. The marking must clearly show that the conductor is an earth, either by using the letter E or by using an earthing symbol placed at the termination point. Clause 3.9 Installation requirements. This clause introduces the general rules for how wiring systems must be installed so they remain safe under normal use, wear and tear, and any unusual conditions that can reasonably occur. Clause 3.9.1 General. Wiring systems must be installed following recognized safe practices. They must be installed in a way that protects the installation against mechanical or electrical failure, both during normal operation and under conditions that may arise over time. Any installation method that is used must take into account external influences that may affect the wiring system. Clause 3.9.2 Methods of installation. This clause explains that many acceptable wiring methods exist, and examples are listed in Table 3.1. Other methods may be used as long as they meet the general requirements of this section and take external influences into account. If a relevant product standard applies to a wiring system, that product standard takes priority over this clause. Clause 3.9.3 Support and fixing. This clause explains how wiring systems must be supported and secured so they remain safe and do not move or sag over time. Clause 3.9.3.1 General. Wiring systems must be supported by suitable means as required earlier in Clause 3.3.2.8. They must be fixed using clips, saddles, clamps, or any method that does not damage the wiring and is not affected by external influences. When wiring is installed in a building structure, the size and position of any openings must not weaken the structural strength required by building codes. Where sheathed cable passes through metallic structural members, an aperture must be bushed or shaped so that the cable is not damaged. If the wiring is likely to be disturbed, the cable must be fixed at a point near the opening. Clause 3.9.3.2 Suspended ceilings. Wiring installed above suspended ceilings may be supported by the ceiling system unless the ceiling manufacturer prohibits it. Cables must have extra protection in any place where they may be damaged by ceiling runners or other conductive supports. Wiring above suspended ceilings must be fixed at suitable intervals so it does not sag. Clause 3.9.3.3 Wiring systems likely to be disturbed. Some locations require extra support because the wiring is more likely to be touched, moved, or affected by normal activity. This includes wiring on the surface of walls or ceilings, wiring between a floor and an area where people may gain access, wiring in ceiling spaces with access heights over 0.6 meters, wiring within 2 meters of any access point, and wiring under raised floors. Clause 3.9.4 Protection against mechanical damage. This clause explains where wiring is likely to be exposed to mechanical damage and must therefore be protected. Clause 3.9.4.1 General. Where it is reasonable to expect mechanical damage, the wiring system must be protected in accordance with Clause 3.3.2.6 and the detailed requirements that follow. Clause 3.9.4.2 Wiring systems near building surfaces. Wiring fixed in place by fasteners or passing through structural members must be protected by one of the approved methods if it is less than 50 mm from a wall, floor, ceiling, or roof surface. Protection is also required where the cable is located more than 150 mm from wall-to-wall or wall-to-ceiling corners. These requirements do not apply to wiring systems that can move freely enough to avoid being struck by nails or screws driven into the surface. Clause 3.9.4.3 Wiring systems under wall lining or roofing material. Clause 3.9.4.3.1 Prohibited locations. Wiring must not be installed in the space between roofing material and its immediate supporting members, or in similar spaces behind wall linings where a person may reasonably drive a nail or screw. These locations include the space between battens and roofing tiles, or between corrugated roofing sheets and their supporting members. Clause 3.9.4.3.2, Protection required. If wiring passes through a structural member, or is fixed in position within 50 mm of the surface to which roofing or wall material is attached, one of the approved protection methods must be used. Clause 3.9.4.4, Protection methods. Where protection is required, the wiring system must either have adequate mechanical protection, or be enclosed in an earthed metallic covering, or be protected by an RCD with a maximum residual operating current of 30 mA. Clause 3.9.5, Wiring systems installed vertically. Wiring systems installed vertically must comply with earlier support requirements and must be arranged so that no damage occurs due to the cable's own weight or the method of support. If wiring is enclosed in a vertical riser, cable supports must be placed at intervals not exceeding 8 meters or as recommended by the cable manufacturer. Clause 3.9.6, Change of direction. When wiring systems change direction, bends must be made so that they do not damage the sheathing or insulation. The minimum bending radius recommended by the manufacturer must be followed. If this information is not available, unarmored sheathed cables should have a bending radius of at least 6 times the diameter of the cable, and armored cables should have a radius of at least 12 times the diameter. Any support in contact with the cable must not have sharp edges that could damage the insulation. Clause 3.9.7, Particular requirements. This clause sets out additional installation requirements for specific wiring systems. Clause 3.9.7.1, Consumers' mains. Consumers' mains must be installed so the risk of short circuit is kept as low as possible. Clause 3.9.7.1.1, Protected. Where consumers' mains are protected on the supply side by a short circuit protective device, they must comply with all the relevant requirements of this section. Sometimes the electricity distributor's protective devices already provide this protection. Clause 3.9.7.1.2, Unprotected. Where consumers' mains are not protected on the supply side, the wiring must be constructed to minimize the risk of short circuit and must follow any additional requirements set by the electricity distributor. Certain wiring systems are taken to provide minimum short circuit risk. These include insulated and sheathed cables in heavy-duty insulating conduits, insulated and sheathed cables in underground wiring enclosures, aerial conductors of specified types, and busway systems that provide insulation up to the first protective device. Clause 3.9.7.2, Insulated and sheathed cables. Armored sheathed cables may be installed in concrete or plaster or cement render without an extra wiring enclosure, provided they meet all installation requirements for mechanical protection. Unarmored sheathed cables installed in concrete must be enclosed in an appropriate wiring enclosure that meets the rules for concealed wiring. Clause 3.9.7.3, Mineral insulated metal sheathed cable. This clause deals with MIMS cables. For corrosion protection, these cables must be installed in locations where corrosion is unlikely, or they must be protected by suitable methods. For vibration protection, a loop of cable may be needed before the termination to absorb movement. Supports and fixings must suit the highest temperature that the cable may reach in service, and must prevent damage. Clause 3.9.7.4, Flexible cords used as installation wiring. Flexible cords used as installation wiring must be heavy-duty sheathed types and must be installed using the same rules that apply to insulated sheathed cables. There are limited exceptions where flexible cords do not need to be heavy-duty. These include cords used for pendant socket outlets, cords installed inside a suitable wiring enclosure, and cords used as equipment wiring as allowed elsewhere in the standard. Flexible cords used as installation wiring must follow all requirements of this section and must not be open to view. Clause 3.9.7.5, Low voltage track systems. Low voltage track systems must be installed so the track is open to view for its full length but does not need to be visible from every position. The system must be positioned to reduce dust entry, and the supports must be appropriately designed, correctly spaced, and arranged so the track is held securely without sagging. Clause 3.9.7.6 Undercarpet wiring systems. Undercarpet wiring may be used only as a floor-mounted system, and only in areas not larger than 1 meter by 1 meter. The system must be installed according to the manufacturer's instructions. Systems of different designs must not be interconnected unless the manufacturer specifically permits it. Clause 3.9.8 Prevention of mutual detrimental effects between services. Wiring systems must be arranged so they do not adversely affect other electrical services or non-electrical services. Clause 3.9.8.1 General. This includes preventing detrimental effects between different electrical installations, different parts of the same installation, circuits of different voltages, safety services, non-electrical services such as gas and water supply, and telecommunications or data cabling. Clause 3.9.8.2 Different electrical installations. Conductors belonging to different electrical installations must not be installed in the same wiring enclosure unless proper segregation is provided. Where different installations terminate in a common enclosure, they must be effectively segregated. This may be achieved by using sheathed cables, barriers, or by spacing. Clause 3.9.8.3 Segregation of different voltage levels. Cables of high voltage circuits and low voltage or extra low voltage circuits must not be installed in the same wiring system unless effective segregation is provided. Low voltage and extra low voltage circuits may share the same wiring system only if the cables provide equivalent protection or the cables are enclosed in separate compartments with continuous barriers. Clause 3.9.8.4 Proximity to non-electrical services. Wiring systems must not be installed near services that produce heat, smoke, or fumes unless shielding prevents damage. Wiring below services that may create condensation must be protected. Electrical services must not interfere with the operation of adjacent services. Wiring must be protected from hazards created by the presence of other services. Unenclosed wiring must not be installed where it might be accessible to personal contact or could touch other services such as gas or water piping. When crossing gas or water pipes, wiring must maintain the required minimum separation. Clause 3.9.9 Selection and installation to minimize the spread of fire. This clause covers precautions to help prevent fire spreading through or because of wiring systems. Clause 3.9.9.1 General. Where wiring systems pass through building elements, precautions must be taken to limit the spread of fire. Where equipment contains flammable liquid, measures must be taken to prevent burning liquid from escaping and spreading fire. Where building dimensions increase fire spread risk, precautions must be used so wiring does not contribute to fire propagation. Clause 3.9.9.2 Precautions. Wiring systems must be installed so the building's structural performance in a fire is not reduced. Cables and wiring products with appropriate fire ratings must be used where required. Wiring systems that do not meet the required fire rating may be used only for short lengths when connecting appliances. Segregation between fire-rated compartments must not be compromised. Clause 3.9.9.3 Penetration of fire barriers. Where wiring passes through floors, walls, or other fire-rated elements, the penetration must meet strict requirements. The opening must fit closely around the wiring system, the size of the opening must be limited, and the fire rating of the structure must be reinstated after the wiring is installed. Conduits or trunking systems may pass through fire-rated elements if they meet specified protection and sealing requirements. Sealing systems must be compatible with the wiring materials, must allow thermal movement without losing sealing performance, and must resist the same external influences as the wiring system. Clause 3.9.10 Limitation of circulating and eddy currents. This clause explains how certain wiring arrangements can create unwanted circulating or induced currents, and steps must be taken to limit them. Clause 3.9.10.1 General. Precautions must be taken to reduce circulating currents and eddy currents that may cause overheating. Clause 3.9.10.2 Cables for AC circuits. Single-core cables running through ferrous enclosures such as steel must not be used for AC circuits unless precautions are taken to limit induced heating. Where single-core cables carrying alternating current enter a ferrous enclosure, the conductors must either be arranged so they are not surrounded by ferrous metal or provided with spacing or other methods to prevent excessive heating. Clause 3.9.10.3 Cables with non-ferrous metal sheathing. Single-core cables enclosed in copper, aluminium, or other non-ferrous sheathing may be used only where the installation avoids the creation of excessive heating. Trefoil formation may be used, where the cables are run together in groups of 3 for their full length. Where trefoil is not used, cables must be installed as close as possible to each other. The sheathing must be bonded at both ends and at intervals not exceeding 30 meters to ensure equal conductivity and to control induced currents. Clause 3.9.11 Electromagnetic interference. Some electrical installations may be sensitive to electromagnetic interference created by current in nearby cables. Interference may be reduced by selecting cables with low magnetic emissions, installing cables in enclosures that shield magnetic fields, or arranging cables in configurations that minimize magnetic field strength. Clause 3.10 Enclosure of cables. This clause explains when cables must be enclosed in a wiring enclosure, what types may be used, and how they must be installed. Clause 3.10.1 General. This clause sets the rules for enclosing insulated cables that do not have a sheath. These cables must be enclosed throughout their entire length unless one of the listed exceptions applies. Clause 3.10.1.1 Insulated, unsheathed cables. Insulated unsheathed cables must be enclosed unless they are used in specific situations allowed by the standard. These include when they are used as aerial conductors, when they are inside a wall cavity very close to an accessory or wiring enclosure, when they are inside a switchboard or similar enclosure where they cannot be touched during normal operation, when they are earth or bonding conductors installed under Section 5, or when they are extra low voltage conductors under Section 7.5. Clause 3.10.1.2 Insulated and sheathed cables. Sheathed cables do not always need to be enclosed. However, if the cable's insulation or sheath does not meet the fire propagation requirements of the NZS 5000 series, then the cable must be put inside a fire-rated enclosure. Whenever part of a sheath is removed, the exposed conductors must be enclosed to provide protection similar to a fully sheathed cable. Clause 3.10.2 Wiring enclosures. Clause 3.10.2.1 Types. This clause explains what types of wiring enclosures may be used. These include steel conduits and other metal tubing, flexible metal conduit, rigid and flexible insulating conduit, corrugated insulating conduit, and cable trunking systems. Any other enclosure may be used if it provides at least the same level of mechanical protection as the ones already listed. Where unsheathed cables are enclosed, any removable cover must be fixed so it cannot be taken off without tools when it is in an accessible place. Clause 3.10.2.2 Change of wiring enclosures. Whenever a cable moves from one type of enclosure to another, the change must occur either at a switchboard or through a suitable device that protects the insulation and maintains continuity of any conductive enclosure. Clause 3.10.2.3 Entry of water. Wiring enclosures must be installed to prevent water entering equipment or the enclosure. Where exposed to the weather, they must include suitable protection to stop rain entering. The installer must consider the height of each end of the enclosure, because the lower end may be more likely to allow water entry. Clause 3.10.3 Installation of wiring enclosures. Clause 3.10.3.1 General. Wiring enclosures must be installed following safe and sound practice and must provide the degree of protection set out in earlier clauses of Section 3. Clause 3.10.3.2 Support. Enclosures must be supported so they are not damaged and so they do not damage the cables inside. Clause 3.10.3.3 Continuity. Metal enclosures must maintain both mechanical and electrical continuity unless the standard specifically allows them not to be earthed, such as when they contain only insulated and sheathed cables. Clause 3.10.3.4 Bending. Every bend in a wiring system must be made so the cables are not damaged. Rigid conduit must not be bent so tightly that the internal diameter is reduced. Where trunking or ducts are used, any change of direction must allow the cable to meet the bending radius requirements stated earlier. Clause 3.10.3.5 Passage for conductors. When cables pass through metalwork such as tubes, channels, conduit ends, or openings, they must be protected. If the opening is bush, the bush must be securely fixed. If it is not bushed, the edges must be smooth with no sharp projections that could damage the insulation or sheath. Clause 3.10.3.6 Terminations. Wiring enclosures must terminate and be supported so that cables passing into equipment are fully protected. Flexible conduit must be securely anchored to the equipment where it terminates. Clause 3.10.3.7 Installation in direct sunlight. Rigid insulating conduit fittings, and cable trunking systems installed in direct sunlight must either be designed for sunlight exposure or be painted with a suitable light-colored acrylic paint that reduces heat buildup. Clause 3.10.3.8 Provision for expansion. Rigid insulating conduit must be installed with allowance for thermal expansion. As a guide, a 10-degree temperature rise causes about 1 mm of expansion per meter of conduit. Clause 3.10.3.9 Cable trunking. Cable trunking must be installed so that its covers can be opened where practical, and covers must be continuous when passing through walls or floors. The full length of the trunking must remain accessible. Trunking must not rely on removable covers for cable support. Non-hygroscopic trunking must be used when enclosing insulated unsheathed conductors. Any live parts of accessories mounted on trunking must be arranged so that basic protection is provided, consistent with Clause 1.5.4. Clause 3.11 Underground wiring systems. This clause explains how underground wiring must be selected, protected and installed so that it remains safe throughout its life. Clause 3.11.1 Suitability and protection. Any cable installed below ground must be suitable for the soil or environment it is placed in. It must also be protected against accidental damage, especially from digging or machinery. Where there is any chance that the cable might be struck during excavation, suitable warning systems, markings or protective measures must be used to reduce the risk. Clause 3.11.2 Classification of wiring systems. Underground wiring systems are grouped into 3 categories. The category depends on the type of cable and the amount of enclosure or mechanical protection provided. A Category A system is considered inherently suitable for below-ground installation and generally does not need extra mechanical protection. A Category B system is suitable for below-ground installation but requires added mechanical protection. A Category C system is one in which the cable is laid in a channel chased into rock. Underground wiring must use the types of cable allowed for that category and must follow the permitted installation methods for that category. Clause 3.11.3 Arrangements. This clause describes the arrangements that qualify as Category A, Category B, or Category C systems. Category A systems may use heavy-duty insulating conduit, insulating wiring enclosures encased in concrete, or sheathed cables buried directly in the ground where permitted. Category B systems include cables enclosed in medium-duty conduit with added mechanical protection, or sheathed cables buried directly with protection provided. Category C systems are used when the cable is laid within a rock channel and then covered with concrete. Examples of each arrangement are given for illustration, but the key idea is that the cable type and the enclosure must match the intended category. Clause 3.11.4 Installation requirements. This clause outlines how underground wiring must be installed to remain safe from mechanical damage and environmental effects. Clause 3.11.4.1 General. Underground wiring must follow the specific requirements of the later subclauses, which include bedding, mechanical protection, minimum depth of cover, and correct identification. Clause 3.11.4.2 Unenclosed cables. If cables are not installed inside an enclosure in a Category A or B system, they must be laid on a bed of fine material at least 50 mm deep. They must also be covered by at least 50 mm of the same type of material. This bedding prevents stones or sharp objects from damaging the cable. Clause 3.11.4.3 Category B Mechanical protection. A Category B system requires additional mechanical protection. This must be placed not more than 75 mm above the cable, and must be at least 150 mm wide. The protection must also extend at least 40 mm beyond each side of the wiring system. This protection may be provided by precast slabs, cast-in-place concrete, continuous concrete cover, fibrous cement slabs, bricks, polymeric cover strips, or other materials that provide an equivalent degree of protection. Clause 3.11.4.4 Minimum depth of cover. Underground wiring must be buried to a depth suitable for the specific installation. The required depth depends on whether the wiring is inside a building, beneath poured concrete, or out in natural ground. The minimum depth is based on the top of the wiring system, or on the top of the mechanical protection layer if used. Clause 3.11.4.5 Identification of underground wiring. Underground wiring must be identified with orange marker tape. The tape must meet the requirements of the relevant standard and should be positioned roughly halfway between the wiring system and the ground surface, or halfway between the wiring system and the top of the mechanical protection. Where the wiring is chased into rock, the tape must be laid directly above the cable before concrete is poured. Where underground wiring is installed by directional drilling, tape may be omitted as long as the location of the wiring is permanently recorded so it can be found by anyone digging in the future. If a pipe or conduit is left in place after drilling, using an orange conduit is recommended for clear identification. Clause 3.11.4.6. This clause is about making sure we always know where underground cables are, so they don't get damaged when someone digs. First, we must put a marker sign showing where the cable goes into the ground or comes out near a building. If this point is already very clear, then a sign is not needed. Next, the path of the cable must be drawn on a plan so future workers can find it. That plan must be kept at the switchboard where the circuit starts. For consumers' mains, the plan must be kept at the main switchboard of the building. If the underground wiring is fully inside a building area, marking is not required. Clause 3.11.5 Spacing from other underground services. Underground wiring must be separated from gas, water, stormwater, sanitary drains and telecommunications services by a safe distance. This distance depends on the type of service but is never less than 100 mm. The wiring must also be marked with suitable warning tape when required. Additional requirements apply for separation from telecommunications, gas and water services, as described in earlier clauses. Table 3.7 gives the minimum separations. The exact numbers vary depending on the service, but the key idea is that low-voltage electrical wiring must be kept enough distance away from other underground services so that damage or faults in one system do not affect the other. Some exceptions apply, such as when services are installed in the same trench but kept in separate enclosures, or when conductive enclosures are bonded to the electrical earthing system. Clause 3.12 Aerial wiring systems. The standard reminds us that aerial wiring may not be allowed in some places, especially areas with a high bushfire risk. Local authorities and the electricity distributor may place limits on this type of wiring. Clause 3.12.1 Types of conductor. This clause explains what types of conductors are suitable for aerial wiring. Aerial wiring can use bare hard-drawn conductors, or insulated polymeric cables, or neutral screened cables, or insulated cables that are twisted, bundled, or webbed together. The idea is that only conductor types designed to withstand environmental exposure can be used overhead. Clause 3.12.2 Arrangements. Clause 3.12.2.1 Insulation of aerial conductors. Aerial conductors must be insulated in several situations. They need to be insulated when they are attached to a building or structure. They need insulation when the cable span is close enough for someone to reach from a building or an opening. They need insulation where sailing craft or irrigation pipes may rise up underneath the line. And insulation is required in areas at risk of bushfire when the authority says so. There is an exception for conductors that are fully supported by two independent poles or similar supports, as long as the span is not connected to a building. Clause 3.12.2.2 Minimum size. Overhead conductors must meet minimum size rules to ensure strength and safety. Copper or aluminium conductors need at least 7 strands, with copper no smaller than 6 square millimeters and aluminium no smaller than 16 square millimeters. Steel conductors need at least 3 strands. The idea is that overhead conductors must be strong enough to resist wind, tension, and long-term sag. Clause 3.12.3 Clearances. Clause 3.12.3.1 General. Aerial conductors must be installed with enough clearance from the ground, from buildings, and from structures. The clearances are set so the conductors stay safely out of reach under normal conditions and when they sag in hot weather. If the conductor will run hotter, or if extra sag is expected, more clearance must be added. When conductors end at a building or structure, the installation must prevent anyone from touching them accidentally. Clause 3.12.3.2 Safety warnings. Where there is a reasonable chance that people may contact aerial conductors, warning signs or other notices must be installed. This includes areas with sailing craft, locations where long irrigation pipes may be moved around, places where high vehicles load or unload, or anywhere else where unexpected contact might occur. Some authorities may require extra signage near waterways. Near aerodromes, extra warnings may be required to alert aircraft. Clause 3.12.4 Distance between supports. This clause gives the maximum span allowed between supports for different overhead conductor types. The span length depends on the conductor size and construction. Longer spans may be used only when a qualified engineering design confirms the installation is safe. Clause 3.12.5 Aerial conductor supports. Supports must be suitable for the conductor type and must be designed for overhead use. Pin-type insulators must not be used when the conductor strain might pull the wire off the insulator, or when the line changes direction by more than 30 degrees. The idea is to avoid mechanical stress that could make a conductor come loose. Clause 3.12.6 Poles and posts. Poles and posts must be made from materials suitable for the conditions in which they will be used. They also need to be installed to the correct depth for the soil type. If the ground is very solid, such as rock, the depth may be reduced. If the ground is weak, the pole must be installed deeper or supported by other means. Clause 3.12.7 Joints and connections. All joints and connections in aerial conductors must follow the same installation rules as other cable joints in the standard. They must be mechanically sound and provide proper electrical continuity and insulation. They must also be protected against weather where required. Clause 3.13.3 Clearances. This clause explains that cables supported on a catenary wire must keep safe clearances from buildings, structures and equipment. Outdoors, the clearance must match the requirements for a neutral screened aerial cable. Indoors, the cable must stay at least 100 mm away from any moving parts or from equipment that runs at a high temperature. These clearances help prevent damage to the cable and reduce the risk of electric shock or fire. Clause 3.14 Safety services. This clause explains that any wiring used for a safety service must meet all the normal installation requirements in this section and must also follow the extra rules set out in section 7.2. Safety services must continue operating during faults or emergencies, so their wiring has stricter reliability and protection requirements than general wiring. Clause 3.15 Busways including rising main systems. This clause explains that busway and rising main systems must comply with as NZS 3439.2 and must be installed exactly as the manufacturer instructs. Where a busway passes through a fire-rated part of a building, the installation must also meet the fire penetration requirements in Clause 3.9.9.3 so that the fire barrier remains effective. Clause 3.13 explains wiring systems that are supported by a catenary wire. When cables are supported in this way, they must be stranded cables that provide double insulation or an equivalent level of protection. If these cables are installed outdoors, they must also be suitable for direct sunlight. A cable is considered properly supported when it is carried by a catenary wire so that mechanical stress on the cable is reduced. The catenary support must give even support, be made from a material that resists corrosion, be securely fixed at both ends, and be able to handle the mechanical forces that may occur, especially from wind or ice. It also needs to be mounted high enough above the ground so it does not create danger for people, animals or property. Cables on a catenary must keep the same clearances as a neutral screened aerial cable outdoors, and when used indoors must stay at least 100 mm away from moving parts or from equipment that operates at high temperature. Clause 3.14 explains that wiring systems used for safety services must follow every requirement in this section, and must also follow the extra rules in Section 7.2, because safety systems must remain reliable during faults and emergencies. Clause 3.15 explains busways, including rising main systems. These systems must meet the requirements of AS NZS 3439.2 and be installed exactly according to the manufacturer's instructions. Whenever a busway passes through a fire-rated part of a building, it must also meet the fire penetration requirements described in Clause 3.9.9.3 so that the integrity of the fire barrier is not reduced. That brings us to the end of Section 3. In this lesson we worked through how wiring systems must be chosen, how they handle external influences, how clearances and support systems work, and how underground and aerial wiring must be installed. All of these rules share the same purpose: to keep the installation safe under normal conditions and under the unusual conditions that can happen over time. If you ever feel unsure in practice, come back to the core ideas from this section, choose the right wiring system, protect it from harm, support it well, and make sure the installation stays safe for the people who use it. When you are ready, we will move on to the next section of the AS NZS 3000.